Welcome. In this lecture, we're going to go through implicit differentiation, which is a way to differentiate functions which are implicitly defined. So then I need to tell you what we mean by implicitly defined functions. So let's start with explicitly versus implicitly defined functions. So usually we require that functions are, so in this case, this function are going to be explicitly defined. So explicitly defined. Right. So for example, I would have the graph of, so I have x and then y. And then this explicitly defined function would look like I could have, I think this one in particular is going to look kind of like this. I apologize, it isn't perfectly drawn, so this is y equals x plus e to the x. And so why is this implicitly defined? Because y stands alone on one side, is how you could kind of think about it. Alone on one side. Right, and everything on the other side is like only has to do with x. Okay? And maybe I'll even include that in everything. So everything on the other side only has x in it. Okay, so that's what we mean by an explicitly defined function, right? For this to work like this, so this is, you only have one possible y output for each x input. It has to pass this vertical line test. What we're used to thinking of as a function is an explicitly defined function. But sometimes we allow and I'm going to make this red, even though normally our graphs aren't red, just to kind of indicate something different's going on. So implicitly defined. So sometimes we allow them to be implicitly defined. Okay, so what can this look like? So I have my graph, so I have, I have this graph, so I have like x, and then I have y, right? But it's possible to have more than one x value, more than one y value for a given x value. For example, if I wanted to draw a circle like this, where it's written as x squared plus y squared equals 25, for example, right? So this is a circle of radius 5. So that's sometimes something we actually want to deal with. It's just called implicitly defined. So now we need to be very careful in how we actually differentiate something like that. So to differentiate implicitly defined functions, so to differentiate, I guess we'll continue with this course and write implicitly defined functions. So implicitly defined functions. Right, we're going to use this new method, which is called implicit differentiation. And really, it's just very careful use of the chain rule. Use implicit differentiation. Okay. So Here we go. So step 1 is going to be, I feel like I'm in a mood to use more colors. So 1 is going to be that we're going to kind of take the derivative with respect to x of both sides. But this really needs to be done carefully because, right, we know that, but we have that y is a function, but y is a function of x, so is a function of x. So we have to use the chain rule. Okay, so have to use the chain rule. Okay, so let's go ahead and look at how this works. So I'm going to take, I'm going to do this with this particular function here. So I'm going to have, so I have it kind of written as I have x squared plus y squared equals, and then I'll kind of give enough room so that we can do this properly, so equals 25. And then I need to take the derivative with respect to x of both sides. Okay, now this is where I kind of need to be careful, so I'm going to be very careful. And what am I going to get? So I'm going to get, well, we can still break this apart and do this one and then this one. Okay, so when we take the derivative with respect to x of this one, so we're going to get 2x times the derivative with respect to x of x. Okay. Right, because 2x is the derivative of this. I'm putting this in just to kind of emphasize that this one isn't going to do anything for us, but the other one is. So this one I'm going to do 2y, and then I have to do the derivative with respect to x of y. Okay. And then on the other side, I just get 0. I'm taking the derivative of a constant. So this is going to equal 0. Okay, and then we do a little bit of being careful here. Right, this is just 1. So, you know, kind of cleaning this up, I get that, and finishing this, I get 2x multiplied by 1, so that's done, and then plus 2y, and then we just write this as dy dx. We don't know what that is. In fact, that's actually what we're looking for. Okay, so we have 2y dy dx equals 0. Great. Now we're going to solve for dy dx. So I'm going to decide that this is going to be green, so we're going to solve for. Okay, so in the next step, I need to solve for dy dx. Like, we need to isolate it and get it all on its own on one side. Okay, so the first thing, right, let's just kind of write this. So we have, so we'll just kind of start this here. So we have 2x plus 2y, and then we have this critter that we're going to need to isolate. So this has to equal 0, right? So we need to solve for or isolate. So isolate. So we had to start like subtracting things off and so on. So let's subtract the 2x from both sides. So I get 2y, then I have dy dx. And then I subtracted the 2x from both sides, so I get minus 2x. Okay, so what did I do here? And I'm going to use red to kind of emphasize what I'm doing. Okay. So what did I do here? So minus 2x from both sides. And then now I just need to divide both sides by 2y, so I get dy dx is going to equal, and then I'm going to be done, this is going to be minus 2x over 2y, i.e. dy dx equals minus x over y. Okay, so over here I just did divide both sides by this 2y here. Okay, now it almost looks like we're done, right? And sometimes we are. I just want to point out that sometimes you actually kind of solve for y and plug that in there. Okay, but we're not going to do that because you can't actually really solve for it in here. Okay, so let's like go through what we did. This is an implicitly defined function because, you know, it doesn't pass the vertical line test. It's kind of all mixed up, the x's and the y's. So how do you differentiate such a function? You use implicit differentiation. How do you do that? The first thing you do is you take the derivative with respect to x at both sides. Some students just think of it as every time you're doing anything with a y in it, you have to leave a dy dx next to it. But sometimes you might make mistakes. So it's good to just use a chain rule very carefully. So I get 2x, right, for that derivative, times the derivative with respect to x of x, which is just 1. But when we do it with this one, we get 2y, and then we have to take the derivative with respect to x of y, and we actually get, ooh, this should be a dy dx. Okay. But then, right, and we took the derivative of a constant, so that was 0. There was nothing complicated there. And then we have to solve for or isolate this because this is what we actually want. And we just do that. We subtract 2x from both sides to get this. Then we have to subtract or divide both sides by 2y. We get this, which we can like simplify a little bit. And then when we get dy dx is actually equal to minus x over y. Okay, so I hope that made some sense. And I will see you in the next lecture.